In the previous chapters, we have learned about the graph and the equation of a straight line. So in the following discussions, we are going to learn the function and the function notation. Now, let's say we have two sets of data, right? Usually we can relate the two sets of data together, and we call that a relations. So you can see here on the left hand side, we have a set of data about celebrities. And on the right hand side here, we have another set of data that is about the nationalities. So can you relate them? Right, so now we know this Angelababy she's from China, and Li Hong is from Taiwan, and Siti is from Malaysia. Right, so we can actually relate two set of data in the form of X and Y, where the X is actually from uh, one set and the Y is actually from the set Y. All right, so then we can actually represent the relations like something like that. Angelababy, China, Li Hong, Taiwan, and Siti is from Malaysia. Right, we call this a relations. So a relation between two sets X and Y is a set of ordered pairs, each of the form XY, where the X is a member of set X and Y is a member of set Y. Now, there are four types of relations, right? Namely, one-to-one relations. So you can see here when it is a one-to-one relation, each element in set X is related to one and one only element in set Y. So we call this one-to-one relations. Now the second type of relation is called many-to-one relations. Now as we can see here, right, many elements in set X is related to one element in set Y. So we call this many-to-one. Now the third type of relations is one-to-many relations. Okay, so you can see here, all right, one element in set X is related to many elements in set Y. So we call this one-to-many. And of course, the fourth type of relation is many-to-many relations, right? Many elements in set X is related to one element in set Y, and at the same time, one element in set X is related to many elements in set Y. So we call this many-to-many. Now, when we come to function, now a function is actually a relations, right? But one value of X is only assigned to one value of Y. Okay, now, so let's see whether each of the relations below here, are they function? Now, number one. Now, is one value of X assigned to one value of Y? Yes. So therefore, this is a function. All right, now how about the second one? Right, now is this one value of X assigned to one value of Y? Right, yes. Okay, because we have, although there are many assigned to one value of Y, but one value of X is only assigned to one value of Y. Okay, so many-to-one relation is also a function. Now, one-to-many relations, all right, from here, is one element assigned to one element in Y? No, all right, therefore, this is not a function. And how about many-to-many relations? No, because, all right, there is one element here assigned to many element in Y. So the function, right, is only limited to one-to-one relations and many-to-one relations. Now the variable x, right, we call that independent variable because the x is the input that is required. So this value usually we give it, right? We assign. And the variable y is called a dependent variable, right? Because we will actually find the value of y when the x is given. All right, so this is the formal definitions of functions. So let the x and the y, they are the sets of real numbers. Okay, a function f, right, of real variable x from x to y is correspondent that assign. So this is the keyword, all right. Each number of x, right, is exactly assigned to one number in y. Okay, so 1x is assigned to 1y. It can be the same y, just like this one. It can be the same y, but it must be 1x assigned to 1y. Okay, now we are going to learn about the domain and the range. Now, what is the domain? The domain refers to the possible value of x, and the range refers to the value of y that is mapped from x. Now, let's take this example to understand the function better. Now, let's say we have a function. All right, this function is defined as x squared plus 7. Right, so now take note that, right, we can actually imagine that now we have two sets here. So this is the x. So x after the process, or we call function, right, x become x squared plus 7. And the answer here is the y. So sometimes we will say the y is the fx, right, which is the x squared plus 7. All right, so the y is the output. X squared plus 7 is the process. All right, so x squared plus 7 will give us the y. Okay, now let's see what happened here. Right, so when we have f3a, so this 3a is actually the input, right, because the x is the input. Now when we have 3a has the input, therefore this x here, it will become the input. So we are going to find the output in this way. So we replace the x with the input 3a, and when we solve this, right, we have 9a squared plus 7. So this is actually the y. Okay, now for question B, all right, f b minus 1. So this b minus 1 now is the input. So we are going to replace the input here with b minus 1 square plus 7. All right, the input is here. So b minus 1 square plus 7. And when we have b minus 1 square, when we expand, we have b square minus 2b plus 1 plus 7. And we have b square minus 2b plus 8. Okay, so right, we are going to discuss these two examples only. C, we will discuss later in the differentiation. So the form, right, the formal answer will be like this.